So let's take it afresh. Taking it afresh, I said that we are dealing with the rules for IUPAC nomenclature of organic compounds. And number one rule is to identify the parent chain. Now, in identifying the parent chain, this is how you do it. A, the parent chain, that's 1A. The parent chain is the longest continuous chain of carbon atoms. Longest continuous chain of carbon atoms, which must possess the functional group of highest priority. Am I too fast?
No.
Which must possess the functional group of highest priority, comma, as many functional
The
groups,
highest group of what?
which must possess the functional group, not highest group, the functional group of highest priority, which must possess the functional group of highest priority, comma. Should I continue?
Yes.
As many other functional groups and substituents as possible. As many other functional groups and substituents as possible. Should I continue?
Yes.
And as many multiple bonds as possible. And as many multiple bonds as possible. And as many multiple bonds as possible. Are you done? Done? So the conclusion of that statement is that the parent chain is the like most crowded chain. Do you understand what I'm saying? Like the part of the chain that is where there is more crowd, that's the parent chain. That's the point. I hope this is clear.
Yes.
So it's possible you can have a longer chain, but if that longer chain is not crowded, it is not part of it's not the parent chain, it's a substituent. So just take note of that, that the parent chain is the most crowded part or the most crowded chain. Okay, we go to B. So 1B, you now write allocate locants. Allocate locants or serial numbers. Allocate locants or serial numbers. Allocate locants or serial numbers. Allocate locants or serial numbers to the carbon atoms of the parent chain. To the carbon atoms of the parent chain, starting from the end closest to. Starting from the end closest to. Starting from the end closest to the functional group of highest priority. Starting from the end closest to the functional group of highest priority. Are you done?
Yes.
Good. Then you put down this NB, like note by. You write, if the position of the functional group of highest priority, if the position of the functional group of highest priority if the position of the functional group of highest priority does not affect the numbering, comma, does not affect the numbering, comma, it is then numbered such that the multiple bonds, substituents, and other functional groups will have the lowest possible number. um
Such that
the lower functional groups,
such as the multiple
okay, such
bonds.
that the multiple bonds, comma, lower functional groups and other substituents will have the lowest possible number. Will have the lowest possible number. Okay, we'll talk about that. Just don't necessarily pay attention to that. I will explain that later. Then let's go to C. But generally speaking, see what this means. When you are giving number, if for instance you have this, look at this compound. Look, CH3, CH2, CH2, COH, CH3, CH3. Now, what is the functional group of highest priority here? Based on what you wrote, which functional group is the highest here?
Alkanol.
Correct, alkanol. Good. Which means because this is the functional group of highest priority, when you are giving number, you start giving number from the side that is closest to this OH. Am I going to start from the left or from the right?
From the right.
Good. So that's 1, 2, 3, 4, 5. That's that. So if you are naming this compound and the name of this compound is 2-methyl pentan 2-ol, that's the name. But we'll talk about that later. But for now, hope this is clear. Let me now ask a question from what we did yesterday. Is this a primary, secondary, or tertiary alkanol? It is a.
Wait. It's a tertiary alcohol.
Correct. It's a tertiary alkanol. Okay, so let's take this out and continue our rule. So let's go to, which one are we going to now? B, C, D, which one? We're in C, right?
Yeah.
Okay, so right. When naming the parent chain, comma, the root word that corresponds to the functional group of highest priority, the root word that corresponds to the functional group of highest priority is first attached to its appropriate primary suffix. Is first attached to its appropriate primary suffix. Its appropriate primary suffix, which indicates level of saturation. And then the secondary suffix is added to indicate the functional group of highest priority. And then the secondary suffix is added to indicate the functional group of highest priority. Are you done?
Yes.
Okay, now write note NB. So you write the lower locant of a multiple bond. The lower locant of a multiple bond is used to indicate the position of the multiple bond. The lower locant of a multiple bond is used to indicate the position of the multiple bond. Is used to indicate the position of the multiple bond. Are you done?
Yes.
Okay, that's that. Okay, then basically good stuff. Then you just add as an extra. Uh, the position of the position of the functional groups. The position of the functional group is also indicated. The position of the functional group is also indicated. Okay, so let's continue. Um, I think that's that about naming the parent chain. Yeah, that's that. There's no other thing. So let's consider. We are not done with naming, no, but this is naming parent chain. That's number one. Number two is naming prefixes. Once you understand naming parent chain and naming prefixes and put them together, you've understood naming organic compounds. So let's consider something. For instance, if we are to consider this structure, let's look at this structure. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 1, 2, 3. And then I have OH. And here I have Cl. Here there's a double bond. Here there's a double bond. Okay. Let me just add a little more. Here I have NH2, basically, and here I have H. Possibly let me add one more. Let's add OH here. Okay, good. Now, the parent chain. Let's go to rule number 1. Identify the parent chain. And we said that the parent chain is the longest chain of carbon atoms. Are you listening? Which must possess the functional group of highest priority. So my question is, are we going to start counting from this side, or this side? Where is the functional? Which one is the functional group of highest priority first? What's the functional group of highest priority? I have OH, I have amine, I have chlorine, I have carboxylic. Which one is the highest? Which one is the highest? Don't you have your notes? Mona, are you still here? Mona?
Yes.
Oh, yeah. So I said which one? I couldn't hear you.
Carboxylic.
Carboxylic, correct. So that means we are going to start the chain from that side that you have carboxylic and then go up. Now, you notice that if you count, are you going to go towards the left or towards the right? Remember, one of the tricks I used is the most crowded carbon side is the parent chain. So which side is more crowded, left or right?
Left.
This is left though. So left is more crowded. Are you not saying that here is more crowded? It's no longer. In dealing with this thing, before you consider length, the first thing you check is functional group of highest priority. Then you check for multiple functional groups. Then you check for multiple bonds before you consider length. Length is the least thing you consider. Crowded is where do you have more things attached to the carbon? Is it on this side or on that side? Left or right?
On the right.
Exactly.
Right.
So that side that you have more crowd becomes your parent chain. So notice that I'm only secluding the carbon atoms you get with the functional group of highest priority, so that I will know clearly that every other thing outside is a substituent. We'll discuss that. Now, what is the next thing you are supposed to do after doing this? Look at rule number 2. What does rule number 2 say? Yes? What does rule number 2 say?
Allocate locants.
Allocate locants and serial numbers. That's 1, 2, 3. But where are you going to start from? Starting from the side. Continue. Starting from. Hello.
I don't understand.
Can you read the statement you wrote now? Just read the statement.
Allocate locants or serial numbers.
Yeah.
Carbon atoms.
Good.
Of the parent chain.
Good.
Starting from the end.
The end. That's what you wrote.
Starting from the end.
Mm-hmm.
Closest to the functional group.
of
of the
highest
highest
priority.
priority.
Thank you very much. So where are we starting from? Is it this from this end or from that end? Down or right? We are starting from the end of the functional group of highest priority. Is the down? Good. So we are going to number 1, 2, 3, 4, 5, 6, 7, 8. That's all. Did you get this?
Yes.
Good. Now, what's the next rule? Look at the next rule. What's the next rule?
Um, when
Uh-huh.
naming the parent chain,
Yeah.
the root word that corresponds to
Uh, the root word that
the
corresponds to
when naming the parent chain,
uh-huh. I'm
the
listening.
functional group of the highest priority
No,
is first attached to its appropriate
are you
is
sure
first
that's what I?
attached to its appropriate primary
No, I
suffix,
said the
which
root.
indicates level of saturation, and then the second.
Sorry, can you reread this that statement? Let's take it afresh. Oh yeah,
Yeah,
yeah. That's C. The
when naming the parent chain,
uh-huh.
the root
The root word. Good.
the root word
Uh-huh.
that corresponds to the functional group
No,
of
that
the highest
no, no, no,
priority
no, no,
is
no. You missed it. When naming the parent chain, the root word that corresponds to the number of carbon atoms in the parent chain. Please correct that. The root word that corresponds to the number of carbon atoms in the parent chain is attached to an appropriate primary suffix which indicates the level of saturation, and finally the secondary suffix is attached to indicate the functional group of ice. Is that how it is? Is that how it is now?
the number of carbon wait, in the carbon atoms in the parent chain.
Yeah.
The number of carbon atoms in the parent chain should be attached to
Eh,
the
eh,
highest
eh, eh.
priority.
No, Jesus Christ. I said when naming the root word, the root word which indicates, is that what you wrote?
That corresponds.
Okay, the root word that corresponds to the number of carbon atoms in the parent chain, are you there?
Yes.
Is attached to the appropriate primary suffix. Is that what you wrote?
Yes.
Which indicates the level of unsaturation. Then complete it.
Is it indicates the level of saturation?
Level of saturation, yes. Which means it could be saturated or unsaturated. When you say something is saturated, it means that it is filled and it's only single bonds that is there. If it is unsaturated, there is double bond or triple bond. Do you understand?
Yes.
And still talking about this, I believe you can grab this thing. What is used to test or show that something is unsaturated is bromine water. If an organic compound is unsaturated, what you use to test for that is bromine water. The bromine water will change to colorless from brown. Do you understand?
No.
No, you don't need to. Okay, how do I put it? Is that you don't need to understand? You don't need to understand. Just know it. That when you want to show if a substance has double bond or triple bond, use bromine water. Did you get what I just said now?
Yes.
So bromine water. And what happens is the bromine water is brown in color. When you put it inside the substance that has alkene or alkyne, it will change the color from brown to colorless. That's that. Okay?
Yes.
Okay, let's continue. So now can you read it together? So we'll do this. Apply it. Oh yeah, go ahead. What does it say?
When naming the parent chain,
Good.
the root word that corresponds to the number of carbon atoms.
Oh yeah, let's pause.
in the parent chain.
So what is the root word that corresponds to how many carbon atoms? Is 8 now. So the root word here is going to be what? Check. Did you write those root words? The root word for 8 is oct. What did I say is the root word for 8?
Oh.
So OCT. Oct. Good. Continue reading. Continue reading.
The attached to the appropriate primary suffix,
Now,
which indicates
the level of saturation. Now, is this in, an, or ein?
in.
Like ANE?
Yes.
What, An means that there is only single bond though. Is this not double bond?
Mm.
In means that there is a double bond. Ein
In.
means that there is a, so which one is it? In, right?
Yes.
Good. And the in is found between 4 and 5 and between 6 and 7. Now if you look at that NB, check that NB. Before we continue, that NB, what did it say? The lower locant of the multiple bond is chosen. So if you have between 4 and 5, which one are you going to write? 4. Do you understand?
Yes.
Then there is between 6 and 7. So this 4, 6. How many in are here? There are 2 ins. So this 4, 6 die in. Thank you. Then continue. Finish up.
Level of saturation.
Uh-huh.
And then the secondary suffix is added to indicate the functional group of highest priority.
Okay, so what's the functional group of highest priority in this name? Oic bar. How can oic? So we're going to put oic acid. And this is the parent name. Did I say this is the name of the compound? No, this is just the parent name. Is this clear? Is this clear?
Yeah.
Good. Alright, now let's apply the rules. Let's now continue the rules. But did you notice what I did here? Did you notice that between an alphabet
Yes.
and a number, I put hyphen, and then between two numbers, I put comma. But when I was writing in and oic, I did not put any space. So just take note of that. That between a letter and a number,
Yeah.
put hyphen. Two numbers, put comma. Okay, let's continue. So number 2. Number 2. Number 2. You're right. So 2A. You're right. The substituents as well as functional groups of lower priority. The substituents as well as functional groups of lower priority are written as prefixes to the parent name. Are written as prefixes to the parent name. With their appropriate locants. Are you done?
Yes.
Okay, so after that, number 2B, you're right. If a particular substituent occurs multiple times, its locant is repeated as many times as its occurrence. Its locant is repeated as many times as its occurrence. Its locant is repeated as many times as its occurrence. Should I continue? Its locant is repeated as many times as its occurrence. Are you done?
Yes.
Okay, and appropriate words such as die, try, etc. is attached to show the number of occurrence. And appropriate words such as die, try, etc. are attached to show the number of occurrence. Are you done?
Yes.
Okay, full stop. Then we go to the next one, that's 2C, right?
Yes.
If there are different substituents occurring on the parent chain, if there are different substituents occurring on the parent chain, comma, should I continue?
Yes.
They are arranged in alphabetical order as prefixes to the parent name. They are arranged in alphabetical order. They are arranged in alphabetical order as prefixes to the parent name. As prefixes. Yeah, prefixes to the parent name. So the point is, if you have a situation where many of these substituents occurs and they are different from each other, you will now need to arrange them alphabetically before you now name them. Then finally, number 3, attach the prefix name to the parent name. Number 3, attach the prefix name to the parent name, and that's all. Attach the prefix name to the parent name. Okay, let's now name this compound. Look at this. So let's get to the prefixes. What are the prefixes you notice? There is OH. OH is hydroxyl. I see what I'm doing. Then there is amine. When amine is occurring as a prefix, is amino. Then look at this chain here. Anytime you see a saturated chain occurring as a substituent, it is alkyl. A saturated chain of carbon atoms. And how many carbon are here? 1, 2, 3, 4, 5. So this is pentyl. Do you understand?
Yes.
Okay, good. So this is pentyl. Then this is chlorine, which is chloro. Is there any other substituent you are seeing? There's no other one. I don't think there's no other one, right? Right? Now, because there are different substituents, you need to arrange them alphabetically. So if you can you read ABCD? Mona, can you read ABCD?
Yes.
I'm asking a legitimate question. I think I'm joking. So you should be able to read ABCD. Which one will come first? So when we arrange it, who will come first? You see? That's
Amino.
After amino, what else? Yes, what else?
Chloro.
Chloro, good. After chloro, what else?
Hydroxyl.
Hydroxyl. And after hydroxyl, what else?
Pentyl.
Pentyl. Now let's name this. Now, I don't know. Can you see this down part? Can you see this part? This down part.
Yes.
Okay, so let's name this. Now, the first thing we are going to name is the amino. Amino is on number 6. So you write 6 amino. Do you understand? Then we are done with them. Is there any other amino? There's no other amino, so it's just one. Then we go to chloro. Chloro is on number 2, number 3, and number 3. So we'll write it like that. 2, 2, what? It's on number 2, 3, right?
Yes.
There's no other chloro. How many chloro was there? Trichloro. So trichloro. Are you with me?
Yes.
Good. Then now that we are done with trichloro, we now go to the next one, hydroxyl. Where is hydroxyl? Hydroxyl is number 8, so you put it 8 hydroxyl. Are you there?
Yes.
Then the final thing that is there is pentyl. Pentyl is on number 4 carbon, so that's going to be 4 pentyl. Okay, we are done with it though. So after you are done with this, what does rule number 3 say? Rule number 3 says attach all your prefixes to the parent name. This is the parent name, so let's just put the parent name here. That's oct 4,6 dienoic acid. JAMB is never going to ask you this thing, but if you are able to understand how to name this thing, I just applied all the rules in one name so that there will be nothing that will be confusing you when you see the others. But did you get this thing?
Yes.
Good. So put down the structure and then put down the name. Are you done with the structure?
Yes.
Oh wow, cool. Are you done with the name?
Yes.
Oh wow, you've written everything.
Yes.
Okay, very good. So I will give you an example to try, and then I'll now talk about now naming amines is slightly different, and there's just one slight thing I'll just add, and that's that in naming of this thing. Okay, so try this one first. If I give you this structure now, please let me tell you this, once you are given a condensed structure, please, the first thing you're supposed to do is to spread it. For instance, if I give you something like this, CH3 C bracket CH3 bracket OH, then I now put brackets CH2 into 4, then C double bond C, then C double bond C, and then I now put something like C O then H. Then maybe here I added something like NH2, and maybe here I added chlorine, and here chlorine. Now look at this structure. Are you seeing this structure? Hello? Can you see this structure?
Yes.
Good. Now, if you want to expand it, it's simple to expand. What you are going to do is, if you write a carbon, anything in front of that carbon, you surround it before you go to the next carbon. So, how many hydrogen? Hydrogen is 3, so surround it 1, 2, 3. Then you go to the next carbon. So, always, if you see something like this, before you start naming, expand it. Do you understand what I'm saying? Expand it first.
Yes.
So if you expand it here, okay, let's do this. So this is the next C. This, what is in front of that C? There is CH3, put it on top. Then there is OH in front of that C, put it down. Then we continue. Now once you see CH2, just write the CH2 as part of the chain into how many times it is. So CH2 1, CH2 2, CH2 3, and CH2 4. Did you understand this?
Yes.
Then you continue. See, they already told us Br is here. Then you have a double bond, and then there is C. Then this one has NH2. This one is expanded. Then you have another double single bond to C. Here has chlorine. There's double bond here. Here has chlorine. And then finally it ends with this particular guy. So that's this guy. Okay, can you try naming your parent chain?
Yes.
Which one is your parent chain? You will count from the carbon of the highest functional group to the last carbon that you have where it is most crowded. What is it going to look like? So it's straight now. This one is straight, right? This one is just straight. There is no confusion. Include the functional group of highest priority. Is that the functional group of highest priority? Check.
Yes.
Okay, good. Name the compound. Where are you counting from? Left or right?
Right.
Good. Number, name. that quickly. Are you done?
Almost. Uncle.
Yeah, ma. And my name is Godson, not Uncle.
So I should call you Godson.
Yeah, call me
Uncle
Godson.
Godson.
No, Godson. Godson is fine. Go on. Yeah?
What am I?
Okay, you have the name. Go ahead. Yeah, four
What
am
am
I?
I?
Uh-huh. Go on.
5 bromo.
Five bromo. Good. Like where this is going. Uh-huh.
2,3 dichloro.
Okay, thank you. This CL, yeah. Good. 2,3 dichloro. Uh-huh. Uh-huh.
10 hydro.
10
10
hydroxy.
hydro.
10 hydroxyl. Uh-huh. Continue.
10 methyl.
10 methyl. This our name go longer. Uh-huh. 10 methyl
On deck.
on deck.
2,4
2,4.
di in dienoic
That
acid.
is this oic? C double bond O ending with hydrogen. Is it oic? Check your functional groups. When you have a carbonyl group ending terminating with hydrogen, is it not carbonyl? Is this not aldehyde? Oic is COOH. This is CO then H on the side.
Oh,
Have you forgotten?
um,
Check your notes yesterday. I gave it to you.
yes.
So which one is it? Alkanal or alkanoic acid?
Alpha now.
Good. So die in what? Die in what?
Di
Ow. Do you understand?
yes.
Good. That's the name. Good. Good. This is really impressive. Nice. Nice work. Nice work. Nice work. Okay. We'll try out more, Sha. We'll try out more. I'll just give you now. The thing about it is, you